Let f of x be equal to ax square plus bx plus c. There is a function f of x which is a quadratic in x and is given in the form of ax square plus bx plus c, where a is not equal to 0 and alpha and beta are the roots of f of x. So this means that this equation, that is ax square plus bx plus c equals to 0, this has two solutions, alpha and beta, or if I'll write it rather clearly, x equals to alpha and x equals to beta are the two solutions for this equation. Let capital D be equal to b square minus 4ac. Basically the discriminant value, it is assumed to be equal to capital D and its value is b square minus 4ac. Also it is given that alpha plus beta, alpha square plus beta square, alpha cube plus beta cube are in geometric progression. Then mark the correct option, and we have 4 different options here and we need to mark the only correct option. And by the way, this question was asked in JEE 2005 and it was worth 1 mark. But before we trying it together, I would like you to try it on your own. Just give it a shot on your own, and it is completely okay if you get the wrong answer or if you're not able to solve it. We'll try and solve it together and understand what is the approach behind this. I think you might have given some thought behind this. Now let us see what this question actually says. Now the key statement here is that alpha plus beta, alpha square plus beta square and alpha cube plus beta cube are in geometric progression. So let us write them down. Alpha plus beta, alpha square plus beta square and alpha cube plus beta cube, they are in GP. It means they'll have the same ratio. The common ratio will be the same. It means I need to multiply this with some common ratio r in order to get alpha square plus beta square, and again I need to multiply this alpha square plus beta square with the same common ratio, let's call it r, in order to get to alpha cube plus beta cube. So I can write using the property of geometric progression that the ratio of a2 upon a1, which is equal to this common ratio, will be equal to the ratio of third term divided by the second term, which is nothing again but equal to r itself. So now let us put the values. So this will give me alpha square plus beta square divided by alpha plus beta should be equal to alpha cube plus beta cube divided by alpha square plus beta square. Now let's try to solve it further and let's see what do we get here. So on cross multiplying, I'll have alpha square plus beta square whole square is equal to alpha plus beta times alpha cube plus beta cube. On expanding this using the formula of a plus b whole square, I'll have alpha to the power 4 plus beta to the power 4 plus 2 alpha square beta square equals to, I'll just multiply them. So this will give me alpha to the power 4 plus alpha beta cube plus alpha cube beta plus beta to the power 4. On subtracting alpha to the power 4 and beta to the power 4 from both sides of the equation, this and this will cancel out. So finally I'll just have 2 alpha square beta square equals to alpha beta cube plus alpha cube beta. Now what can we interpret from this? Let me take all of them to the one side on the same side of the equation. So this will give me alpha beta cube plus alpha cube beta minus 2 alpha square beta square equals to 0. Now I think I can pull out a single alpha and a single beta from these 3 terms present here. So finally I'll have alpha times beta, and inside I'll have beta square plus alpha square minus 2 alpha beta equals to 0. So this means alpha beta times, now this is this is equal to alpha minus beta whole square. So alpha minus beta whole square equals to 0. So this is the final equation that we got here using the property given in the question, that alpha plus beta and alpha square plus beta square and alpha cube plus beta cube are in geometric progression. Finally, we ended up getting this result, that alpha times beta multiplied by alpha minus beta whole square is equal to 0. Now, in order to satisfy this, in order that this equation is equal to 0, there are two possibilities. Either this term is equal to 0, that is alpha times beta is equal to 0, or alpha minus beta should be equal to 0. Alpha minus beta should be equal to 0. So now from here, I know that my original equation was ax square plus bx plus c equals to 0, and for this we had two roots alpha and beta. So from here I can say that the product of roots is equal to c upon a, this constant term divided by the coefficient of x square. So alpha plus beta is c by a, and I'm using this because if I will concentrate on the options given here, they are in the form of capital D, the discriminant, small b, that is the coefficient of x, small c, that is our constant term. So I need to somehow change my answer in terms of discriminant b, a and c. So in order to do that, alpha plus beta is c by a. So this value I'll substitute here. So this gives me c by a equals to 0. Now if this is equal to 0, this is possible only when c is equal to 0, because a cannot be equal to 0. This was given in the question. This was already mentioned in the question that a cannot be equal to 0. Hence if c by a equals to 0, then this implies that c should be equal to 0. Our constant term should be equal to 0. And from this I can interpret that alpha is equal to beta. It means the roots should be same. We should have coincident and equal roots, which means our discriminant should be equal to 0. This is the condition for equal roots, that our discriminant is equal to 0, which means b square minus 4ac is equal to 0. So we have two conditions, that either c is equal to 0 or d is equal to 0. So combining both of them, I can write c times d is equal to 0, because this equation gives me two solutions, that c times d can be equal to 0 only when either c is equal to 0 or either capital D is equal to 0. And let us check what options do we have here. C times d equals to 0, c times d equal to 0. Our third option C, will be the right answer for this.